All right, so we're going to begin with some basic terms and definitions in the course. All right, so the first thing we're going to talk about is population and sample. So the population is a complete collection of all elements. When we talk about a population and we try to extract information from a population, normally it's well, not normally, but it's basically impossible to contact everyone in a population, right? For example, the census. Every 10 years, the census come out, right, and it asks you a whole bunch of questions. Every individual in the United States is supposed to be accounted and represented, right? But you have people that their address has changed, they no longer have a house or something to that effect. So it's impossible to get information from everybody in a population. A sample is a subset of a population. The sample that you choose or the sample that is chosen, an unbiased sample will represent the population. So you can take a random sample of people, and you're going to hear that word a lot in this course, a random sample. And a random sample is an unbiased sample of people, and the information collected from a sample closely reflects the information of the population. Okay, so a population is the entire collection of elements. A sample is just a subsection. Some examples are of populations, the student body at Aiken Technical College, right? Every student that's enrolled in Aiken Technical College, that would be a population, right? And we run into this often when we try to find responses to certain questions from our student body. The same thing applies. It's impossible to get information from everybody because addresses change, phone numbers change. Some people just not going to answer the survey. All right. So the entire student body they can take would be a population. And let's say a sample of students would be a number of students in a statistics course. Okay. Now, even though you do see the number of students in the statistics course as a sample, that's not necessarily like a random sample. Okay, so when you randomly sample, there is no one particular group because everyone in this statistics course doesn't really represent everybody at the population making tech because you have some students that don't even take statistics. All right. So an important activity in this course is to demonstrate how we can use a sample to form conclusions about a population. All right, next we have a parameter and a statistic. And a parameter is a numerical measurement describing some characteristic of a population. A statistic is a numerical measurement describing some characteristic of a sample. Okay. So some examples are of a parameter. In New York City, there are 3,250 walk buttons, right? So that's all of the walk buttons in New York City that pedestrians can press at a traffic intersection. It was found that 77% of those buttons don't work, right? That is a parameter, and it describes a population. Whenever you are talking about a statistic, you're normally going to see the word sample. So this example says based on a sample, so remember a sample is a subset from the population, of 877 surveyed executives, it was found that 45% of them were not hired because of typographic errors on their job application. So this numerical description, 45% is a statistic, right, because it's taken from a sample. And from that first example, 77% is a parameter because that describes a population. Right? Now, if we take a look at some examples on the handout. Okay, I got it right here. Okay, so the first problem, right, it says determine which of these are parameters and which are statistics. So a key thing is a statistic, you're going to see the word sample or a random sample. And for parameters, not so much. So A says out of a sample of 977 men, it was found that 67% like chocolate. So is that a parameter or a statistic? Statistic, right? This B, using Consumer Reports, a random sample of new cars gave an average of 34 miles per gallon. Statistic. C says in a recent sample of 213 people, it was found that 19% don't bathe every day. That is definitely a statistic, right? And then D, 24% of vehicles sold are compact cars. Parameter, right? So key thing is when you see sample or random sample, that denotes a statistic. All right, now we're going to talk about qualitative and quantitative data. Qualitative data can be separated into categories such as gender, race, eye color, hair color. You can group them into categories. Quantitative data consists of numbers representing counts or measurements, right? So if you're asked to quantify something, that pretty much means to put a dollar amount to it. So like my daughter all the time, well, Daddy, I want some allowance. Okay, quantify how much allowance you want. Is it 50 cents? Is it $1? Daddy, can you take me to the movies? What time do you want to go to the movies? So quantitative data consists of numbers representing counts or measurements. So some examples are the gender of professional athletes. Would that be quantitative or qualitative? Qualitative, because you can group genders, right? I want all men over here, all women over here. The weights of professional athletes, quantitative, because you can put a number for someone's weight or for the weight of an item. All right, taking a look at the handout for problem number 2. It says indicate whether the following variables will be described as qualitative or quantitative. The age in years, quantitative, right? Because that's a number. What about the next one, the number on a soccer player's jersey?
Quantitative. But it's talking about a group of soccer players.
Okay, now it is a number, but does that number mean something? So like if you look at weight, the age in years, the age means something. So a jersey number, that's actually a qualitative. And this is the reason why. If I'm playing football or soccer or whatever, and I got on the number 1, that doesn't mean I'm the best player. That just means I'm number 1. So like you think about Michael Jordan, his number was 23. And some say he's like the best player, so his number is 23. So that's just a qualitative measurement, not a quantitative.
Is it like an identifiable number for that person?
Well, that's what that is. It's just an identifiable number for the But for quantitative, the number has to mean something. So if the number doesn't really mean anything, then it's like a qualitative.
So that's qualitative.
So that's qualitative, right? The age in years is quantitative because the age means something. Okay. That's right. It has to have a meaning. All right. The next one says habits on always, sometimes, or never. Qualitative, right? And then what about the type of residence? Well, they had an example. They said a single family home. So a single family home would consist of how many families? One. So that one means something. So that'll be quantitative. So say if you had a multi-family home, that would just be, you could put a number to it. That number would mean something.
So those are different categories of residences.
Well, the number actually means something. Like a single family home would mean one family, right? Whereas like with the soccer player's number, the number one doesn't really mean the best or the first or that sort of thing. All right, so the type of residence would be quantitative. All right. Okay. No, quantitative. Right, so that age, that number actually means something. All right, the next couple of definitions are discrete and continuous. And for discrete data are items that have a finite or countable number. So for example, there are a discrete amount of people in this class because we can count, right?
Right.
1, 2, 3, 4, 5. Continuous data results from infinitely many possible values. The most common examples of continuous data are weight and time. Okay, so the reason why weight would be a continuous data set, a continuous data, if you get on a scale and you weigh yourself, that scale is actually rounding. So you, like, if I get on the scale, I'm not going to be exactly 245 pounds. I'm going to be like 245 pounds point whatever. Also with time is also continuous because there are infinitely many possible values. Now, when we talk about time, we talk about time in hours, minutes, and seconds. But you can scale hours, minutes, and seconds down even further. You can have hours, minutes, seconds, nanoseconds, microseconds, a billionth of a second. So time is actually a continuous data, all right, because there are infinitely many values, all right? So a couple of examples. Are these discrete or continuous? The number of eggs that hens lay. Is that discrete? Is that a countable set of things, or is that continuous? It's countable, so that's discrete. A hen is going to lay 5 eggs or 6 eggs and like nothing more. You can actually count the number of eggs that the hen lays. That would be an example of discrete data. What about the weight of eggs that hens lay? That's continuous. So just like the weight thing, if you get on the scale, you don't weigh exactly 196 pounds. That scale is like rounding, okay, because the number like keeps on going.
So,
All right.
So one is limited, the other one is limitless.
That's right. That's right. That's right. That's right. All right. Taking a look at the handout. Discrete or continuous. I thought I had these in order. Okay, number 4. Okay, this goes down to number 4, so we're actually skipping 3 for a second. It says determine whether you have discrete or continuous data. The number of hours a student studied in 1 week. That's continuous, right? Because you may say I studied an hour, but you might have studied a little bit less than an hour, might have a little bit more than an hour. You kind of rounding that. So the exact time you were studying is continuous. What about the wage per hour? Discrete. Because you get paid X amount of dollars an hour, and they're not going to pay you anything more or anything less. You can actually count on that. All right. So what about weight? Continuous. What about salary? Discrete. Same thing, because you get paid a certain salary. They're not going to pay you anything more or anything less. You can depend on that, whatever they tell. Okay, so that's discrete. All right. Okay, now the last couple of definitions we're going to take a look at are the levels of measurement. Right, and there are 4 levels of measurement. Nominal data, and that's data that consists of names, labels, and categories. There is ordinal data, and ordinal data is data that can be arranged in some order. Interval data, the differences between any 2 values is meaningful. For ratio, there is a natural zero or starting point. So if you're asked to determine a level of measurement, I will normally start at the lowest level because these things are in order. And I would see if the data represents, names, labels, or categories. If not, then I would go to the next level of measurement to see if you can arrange it in some order. And then I would go to interval, and then I would go to ratio. Now, here's the difference between interval and ratio. Interval data, let me just write this down. Interval data I'm going to say for interval data, 0 is meaningless. And I'm going to give an example in a second. All right, for interval data, 0 is meaningless. For ratio data, 0, and that's the number 0, is meaningful. All right. So on the slides themselves, and that's not actually written on here, but interval data, 0 is meaningless. And for ratio data, 0, it means something. It's meaningful. Okay. So let's take a look at some examples. So now these are in order. Nominal data is the lowest level and ratio is the highest level of measurement. So for nominal, examples are survey questions of yes or no, right? Because yes or no, those are names, categories, or what was the other one? Labels, right? Colors are also nominal data because colors can be categorized. Ordinal data consists of grades, A, B, C, D, because there's like a rank order for grades, right? A is the highest, D is the lowest. Ranks, like first, second, third. Rank could also be like always, sometimes, and never. That's sort of a ranking system in itself. So that's the second level of measurement, ordinal. For interval data, so keep in mind for interval data, 0 is meaningless. So a good example of that is temperature. When it's 0 degrees outside, that doesn't mean that it's not any weather, right? That just means that it's what? Cold. really, really cold, right? So 0 doesn't really mean anything as far as no temperature. Interval data also consists of years, right? And this is the reason why years is considered to be interval data, because there really is no such thing as the year 0. Because the year 0 means when did a year not exist? That really doesn't mean anything, right? So temperature and years, anytime you see those things and you're asked to give a level of measurement, normally they're going to be interval, okay? Because 0 means nothing. Ratio. Remember, ratio data has a true or meaningful 0. So weight would be ratio data, right? Because it's possible for something to weigh 0 pounds, right? And then prices. Prices is also ratio because it's possible for something to be free, all right? So now when we choose the levels of measurement, we're actually just going to go through these levels and we're going to see which level describes our data. All right. So I believe this was number 3. Okay. So the type of residence is that ordinal, nominal, interval, or ratio. So let's go through them one at a time. So for nominal consists of what? Names, labels, categories. So as a type of residence, is that a label, a name, or a category? Right, that's like a category, right? So type of residence would be nominal. Right. What about the number of children? Ratio, right? Because, well, if you go through the list, it's not nominal, right? No label or category. It's not ordinal. You're not really ranking anything. It's not interval, right? Because 0 means something, right? It's possible to have 0 children. So the number of children is a ratio set of data. What about the number of years at a current job?
Years of
The number of years at a current job. Okay, is it nominal?
no.
It's not nominal. Is it ordinal? It's not ordinal because it's not ranking anything. Is it interval? Is it ratio? Now this one, I don't want to say it's a trick question, but you got this word current in here. So if you were to ask me, Mr. Cummins, how long have you been at Aiken Technical College? I couldn't say 0 years.
Oh, that's what
Well, you could say months, but not years.
Or 0 months. Because this word current is in here.
But what if you just started?
Well, if you just started, technically you're working there, so you can't say, I've been working here like 0 years. Is everybody okay with that one? That's kind of a little tricky because of this word current. So you can't say that you have never worked there because that's your current job for 0 years. So that's interval. All right. What about the last one? Habits on always, sometimes, and never. Well, now let's go through them. So nominal, is that a label, a category?
No, would it be no?
sometimes.
That's a category.
Well,
It's ordinal because it's in order.
it's a rank order, right? Always, sometimes, or never. So they're like first, second, or third. Always, sometimes, or never. A, B, C, D. There's like an order to that. Okay. All right. So again, the first one was nominal. Number of children is ratio. Number of years at a current job is interval. Just the key thing, anytime you see like years, that's always going to be interval. And then habits of always, sometimes, and never are ordinal data. All right, so any questions about the definition? You're going to hear me say some of these things. You're going to see some of them pop up in the questions as we go through. All right, so going back to the slide, the last thing in this first set is what is called a frequency distribution. So this is the setup for a frequency distribution. It's a table of frequencies or counts, or it could be tallies, along with their corresponding data. So now for this frequency distribution, they don't really give us what this stuff means. So I'm just going to kind of put a little meaning to it. So we're going to say the first column would represent the ages of people in the doctor's office. The second column represents the number of people in that doctor's office. So the first age level is from 40 to 47. There were like 11 people. From 48 to 55, there are 18. All right, 56 to 63, 13. Okay, 64 to 71 is 8. 72 to 79 is 5. And 80 to 87 is 6. All right, and this is a frequency distribution. So what we're going to be asked to do is to take a data set, and this is like the last problem on the handout. We have to construct this data set into a frequency distribution that uses 6 classes. So I'm going to just go back to the frequency distribution for a second. What are classes? Well, the classes are going to appear on the left-hand side. So here I have 1, 2, 3, 4, 5, 6 classes, right? For each class, you have a lower limit or a lower class number. So you're going to hear me say like lower limit. And then you have an upper limit or an upper class number, right? So the lower limit of, let's say, the third class would be 56. And let's say the upper limit of the last class would be like 87. There is a class width. I can't write on this. But this is how you would find the class width. Class width is found by subtracting consecutive upper class limits or lower class limits. All right, so the class width is found by subtracting consecutive, so that means back to back, upper class limits, or you can use the lower class limits. So if you were asked to find the class width, sometimes they may say class width, sometimes you may see the word class range, but all of that's one and the same. What would be the class width for this frequency distribution? 8. Because I would take consecutive either lower limits, so let's say if I use the lower limits, 48 minus 40 is what? 8. Or I could use upper limits. 55 minus 47 is what? 8. You never want to subtract going across. And that's normally what your mind is going to do, right? So 47 minus 40 is what? 7. But we know our class width is 8. This is because you have to include all numbers. So like you got 40, 41, 42, 43, 44, 45, 46, 47, which is actually how many numbers? 8. But if you were to subtract going across, you're always going to be one number short. So we either subtract upper class limits or lower class limits to find that class width. All right, so now that's actually going to be our starting point for this problem. So we're asked to calculate the class width of the data and construct the frequency distribution for the data set using 6 classes. Enter the lower and upper class limits of each range, fill in the corresponding frequency. We also must find the class width, which is that class, the class range, which is the class width, right? Those are interchangeable. The frequency, right? And we saw those on that example where they gave us the data within the class ranges and the frequency. But we have to calculate the midpoint, the relative frequency, and the cumulative frequency. All right, so I'm going to start by I'm going to pull out the calculator. All right, so if you have your calculator, you may want to pull it out. And I'm going to try to write as many of the steps down as possible. So we want to construct, and this is from handout 1, problem 5. All right, so we want to construct a frequency distribution. So the first thing we want to do is put the data into the calculator. So now the reason I'm using the calculator is, one is because you can avoid human error, because we're going to be looking at this data set, right? We're going to have to find the largest number. We got to find the smallest number. We're going to have to count how many numbers lie between a certain range. And if you're doing that just with your eyeballs, it's easy to make a mistake. And I'm going to just tell you that straight up front. That's called human error, because your eyes get fatigued. This 3 may look like a 5, and I'm telling you, So we're going to use a calculator. So the first thing I'm going to do is put the data into the calculator. So I want to hit stat. Okay, and then once you hit stat, the first option is edit. So I want to use this edit option. So once I hit edit, you should see list 1, list 2, list 3. There are actually 6 lists, right, in your calculator. So if you open up stat and edit and you don't see list 1, because sometimes these lists, they can get out of order. You may see like list 3 first. You can reset your list. So I'm going to kind of show you how to do that. So if I go back to my home screen, so when I say home screen, that's this quit key. And since this quit key is yellow, I must hit second and then mode. And this is what's called the home screen. Okay, in order to reset your list, I can hit stat. Okay, but this time instead of choosing edit, I want to go down to I want to go down to setup editor. If you hit enter once and hit it again, it just says done. It doesn't really seem like it has done anything. But if you go back into those lists, it's not going to clear anything out, but you see like list 1, list 2, and list 3. If you have, let's say, some data in your list, you can go in and click delete, right, and clear each one out individually. Or in order to wipe out the entire list, I can go to the very top. I can hit clear and enter. and that's going to wipe out everything in the list. Now, for our purposes, I'm normally only going to use list 1 and list 2, right? So I'm going to now put the data into list 1. Right? So it doesn't really matter how you go. I'm going to go across. You can go down or however you want to, but just make sure that you're putting 20 pieces of data into the list 1. Okay, 13. And let me just double check, make sure I got the right numbers in. And you want to make sure you got the right numbers in, because if you put the wrong numbers in, then you won't get the right calculation. 13, 14, 41. $23, 11, 48, 35, 46, and 37. Okay. All right, so I'll just give you a second to input that. All right. So once you put in your data, so just notice it says L1 and it says 20. That means I have 20 numbers in my list. Now I want to put it in order, right? Because I'm going to have to find the largest number and the smallest number, and then we're going to just go through that frequency distribution setup. So once you put the data into the calculator, right, we hit stat, and then we chose edit. We put in the data. I want to go back. Okay. Now, at any time when we're dealing with this calculator, if your calculator is not jiving up with my calculator, please stop me and just say, hey, my calculator's not working. Because I had somebody in the last class just was lost because her calculator was doing something crazy. But normally it's just an easy fix. Okay. Oh, I can put that back up too. Now, as far as this problem is concerned, you will see a problem like this on the test. It kind of goes from just the data set and kind of building this data set up to a frequency distribution. And then on other questions, they'll give you the frequency distribution and they'll just ask you questions about it, like what is the class width? What is the lower limit of the third class? But going through this exercise from the beginning to the end, all right, it aids in once you're actually looking at a frequency distribution and being asked those questions. All right, okay. So now once you have the data into your calculator and you double check it, because if you put in a wrong number, you're going to get the wrong output. All right. The next thing we're going to do, I'm going to go back to my home screen. So I'm going to hit second and quit. I'm going to go back into stat. And the second and third options, the second option says sort A, and that's sort in ascending order. So that's going to put your numbers in order from the smallest to the largest. And then you have sort D. That's going to put your numbers in order from the largest to the smallest. I'm going to use sort A, right? So I want to take all of those numbers and I want to put them in order from the smallest to the largest. So that's sort, or number 2. Sort A. All right, so I'm going to hit sort A. I have to tell the calculator which list I want to sort. So we put all of our data in the list 1, right? You can recall list 1. If you look on your keypad above the number 1, I have list 1, and it's a yellow function. So I'm going to hit second, and I'm going to hit list 1, and I'm going to close off that sort function. Right, so we're sorting in ascending order. Right, so I guess on the side I'm just going to write input. Well, I'll just do it exactly how we're doing it. So I hit second, and I hit the number 1, and that gave us L1, right? So now I'm going to hit enter, and it says done. Doesn't really look like it did anything, right? But if I go back into my list, or stat, and I'm going to choose edit, you should now see those numbers in order. Right. So this is about the most important part, because once we have to pick out the frequencies for the numbers within a certain range, we'll be able to easily now do them versus looking at a whole clump of numbers. All right. All right, so is everybody where I am so far? All right. So the third thing we want to do in order. All right, so go back to your home. Second. Continue to. So now you hit scan. Go down to that second option, sort A. And now you want to put in your list. That list 1, so it's yellow, and so it's 1, so you hit second. And then close off the function with the end parenthesis. And now hit enter. it should be sorted. So now if you hit stat, go ahead and do this. And now hit enter. Everything is now on. Okay. All right. So does everybody else have the list ordered? So now this is actually where we're going to start building a frequency distribution. So now the next thing we want to do is we have to find the class width. Right? So this is the formula to find the class width. The class width, we have to take the maximum value minus the minimum or the smallest value, and we have to divide that by the number of classes. Right. So that's the maximum number. So if we look at our list, what's the largest number? 56, right? Minus our smallest number, which is what? 11. And what are we going to divide by? 6 classes. So they must give you how many classes they want you to break it up in. So we're going to take the 56 minus 11, we're going to divide by 6. Right? And this is going to give us our class width or class range. All right. So now anytime you perform any calculations on this calculator, you always want to return to the home screen. Right. So I'm just going to hit second and quit. I'm going to calculate this up. You want to be careful when you're dealing with these fractions. Since I have a fractional bar, I want to put the numerator in a set of parentheses because we want the calculator to follow order operations. Right? So I get 7.5. I'm going to do this a couple of ways. Now I'm going to do it separately. I'm going to put in 56 minus 11, hit enter, right, because you want to simplify the top. Now if I hit divide by 6, I get 7.5. You never want to put this in as 56 minus 11 divided by 6 because the calculator is not following order operations and you will get something entirely different. What the calculator is doing is it's doing the order operations. Please excuse my dear Aunt Sally. And it's dividing 11 by 6, and then it's sort of combining the 56. All right, so be careful when you deal with the fractions. So let me just put that in a set of parentheses. So we get 7.5, right? Now this is one of the key points. You must always round up to the nearest whole number or nearest integer. So we're going to round 7.5 up to 8. Always round up one number. So like there's a problem in the homework. It's going to ask you to find the class width, and you're going to go through all of this. But instead of getting 7.5, you're going to get 10. Or you get like a whole number. You have to take whatever you get and round it up. So let's say if I were to divide and I got 10, I would round that 10 up to 11. Right? Doesn't matter if it's a decimal or not. You always have to round that number up. So our class width is going to be 8, right? So now that we have the class width, we have the numbers ordered, now we're going to construct the frequency distribution. All right, so I'm going to write this out as class range. Next we have the frequency. Next we have the midpoint. Next we have the relative frequency. And we have the cumulative frequency. All right. So now we're just going to fill in the data for this distribution. So the main thing was getting the class or ordering the data in the calculator, and we got the class width. Remember, once you perform that calculation with the class width, you always round up to the nearest integer. So now this is where we start building this distribution. I'm going to go back into the list because I need to pick out some numbers. All right. So now as far as the first class, I'm always going to start with the lowest number. So I'm going to start with 11. Our class width is 8. So what would be the next lower class limit? 19, right? I'm just adding 8. So the next lower class limit is what? 27. And then if we add 8 more, we get 35. Add 8 more, we get 43. And the last, we get 51, right? So I started with the lowest number in the list, and I just added the class width. So now, what would be the upper limit for this first class? 18, right? So now I can do what? I can add 8, right? So 18 plus 8 is 26, 34, 42, 50, and 58, right? Right, because I added 8 to that 50 to get 58. Okay, so is everybody okay with the first part of this, just constructing the class range in those the 6 classes? All right. So now let's fill in the frequencies. So now this is where the calculator really comes in handy, because if you're just looking at a clump of numbers, it's real easy to forget one or add something that's not there. But with the calculator, you can kind of easily pick them out. So how many numbers are in the range from 11 to 18? 1, 2, 3, 4, 5, right? Yeah, 1, 2, 3, 4, 5. So that frequency or count for the first class is 5. How many numbers between 19 and 26? 1, 2, 3. Looks like 3. How many numbers between 27 and 34? Looks like 1, 2, 3, right? between 35 and 42. Go down some more. It's like 1, 2, 3, 4, 5, right? How many numbers between 43 and 50? It's like 2. And then 51 to 58 is like the last 2, right? All right, so those are the frequencies. All right, any questions about the frequency? Now, if you add all these things up, they should add up to give you 20 because there were 20 numbers in that data set. Right. Now we're asked to find the midpoint. So the midpoint would be the number that's in the exact middle of each one of these classes. So in order to find the midpoint, we take the lower limit plus the upper limit and we divide it by 2. So what is the midpoint for the first class? Well, I'm going to go back to my home screen. I'm just going to add 11 plus 18. Divide by 2. And that's not right. I'm forgetting the parentheses. 11 plus 18 in parentheses divided by 2. And we get what? 14 and a half. But now you don't round up for the midpoint.
Oh.
You want to leave the mid. You only round up on the class width. But everything else, you're pretty much using exactly what you see. So the midpoint for that first class is 14.5. The midpoint for the second class is 19 plus 26 divided by 2, 22.5. I guess I can keep doing that until I finish, but is there something else I could do to get these midpoints once I find the first one? I can add the class width. So, for example, if I have 14.5, if I add 8, that gives me 22.5. To find the next midpoint, I could do what? Add 8. Save a little bit of time and, punching keys on the calculator. That's 30.5. If I add 8 again, I get 38.5. If I add 8 again, I get 46.5. And if I add 8 again, I get 54.5. So any questions about the midpoint? So you don't round on the midpoint. You leave whatever that midpoint is, you want to leave it as that number. All right, now we're asked to find the relative frequency. So in order to find the relative frequency, you have to divide the class frequency by the total frequency. Right. So what is the relative frequency for the first class? Right. Well, the class frequency for the first class was 5. Divided by the total frequency, which is what? 20. So 5 divided by 20 gives us 0.25. Well, let me show this with the calculator. Okay, so if I put in 5 over 20, divided by 20. And if I hit equal, it's going to give me the decimal. If the problem asks for a fraction, you always have to write fractions in the lowest form. The calculator will also simplify fractions. So just for example, I put in 5 over 20. I hit enter. It gave me a decimal. I can change this decimal back into a fraction. So if I hit math, and if I use this first option, it'll take whatever it's given and it will attempt to write it as a fraction. I won't say attempt because it doesn't work all the time, but for most problems it does. So if I hit enter once, and this answer thing that you see, answer would be that 0.25. And if I hit enter again, it reduces it down. So if it asks for a fraction, I will put in 1/4. But if it asks for a decimal, I will put in 0.25. Just kind of showing some of the features on the calculator. What is the relative frequency for the second class? All right, well, the frequency for the second class is 3. We're going to divide by the total frequency. All right, so that's 3 over 20. And 3 over 20 is it's already in lowest terms. But if I had to decimalize it, I get 0.15. What is the relative frequency for the third class? Well, that's going to be the same thing, right? Because the class frequency is 3. We're going to divide that by the total. So that's, again, 3 over 20, which is 0.15. The relative frequency for the fourth class, we have the frequency of the fourth class, which is 5, divided by the total frequency, which again is that 0.25. For the fifth class, the relative frequency is 2. We're going to divide that by 20. So 2 over 20 is 1/10, or 0.1. And for our last class, the relative frequency is 2 over 20, all right, which is 1/10 as in reduced terms, or 0.1. All right, so any questions about this frequency distribution so far? All right, now the last column asks for the cumulative frequency. The cumulative frequency is the frequency of the class plus all prior frequencies. So the cumulative frequency is the frequency of that class plus the frequencies of the class before it. Okay. So we're going to see how that breaks down. So what is the cumulative frequency of the first class? Well, it's going to be the frequency of that class, which is 5, plus all of the frequencies before it. And there's nothing before the first class, right? So the cumulative frequency for the first class is 5. What's the cumulative frequency for the second class? Well, the frequency for the second class is 3, plus I have to add all the classes prior. So I got one class prior, which is 5. So 3 plus 5 is what? 8. What's the cumulative frequency for the third class? 11. Right? So this is the pattern, the 3 plus the 3 plus the 5, 11. Okay, so the cumulative frequency for the next class is 16. The next one is 18, and then 20. Uh-huh. Okay.
So, where it says 11 through
18. Okay.
I just want to ask, how did you come up with the 11 through 18 range?
I got you.
Okay.
So remember when we constructed out the class ranges, we started with 11 and we kind of went down.
Yes, sir.
And then for the second class, if it starts at 19, that's right. We kept one back for 18. So everything will kind of follow in order, 11 through 18, 19 through 26. So once I found the upper limit for this first class, I did that by simply subtracting 1. Then I just added 8 all the way down. Okay. All right, and that is the, yeah, so that's how we found the class ranges. Now, as far as this cumulative frequency is concerned, the cumulative frequency must match that total frequency. The cumulative frequency of the last class must match the total frequency. Okay, so if those things are not matching, then you may want to go back and check your cumulative frequency. All right, so I think we're going to stop here for today. Right? Any questions about anything we went through today?
Which section should we be up to?
Well, now this was actually like 1.1 through like 1.3. Now, if you have any questions, particular questions about the homework, just kind of send me an email, and I'm trying to go in, especially for the online students, and make like a video solution of whatever problem. So let's say if there's a problem in 1.3 or something dealing with a frequency distribution, if you send me an email, I'll kind of make a video and I'll post it in all of the classes because your question is probably somebody else's question.